I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on drawing free body diagrams. Alright, so we have a situation here. We've got a physics textbook sitting on a table, and we're going to draw a free body diagram for that situation. So the first thing we're going to do is we're going to draw what's called a system schema. The system schema helps us draw free body diagrams. It helps us not add any extra forces that we may want to add because we show every interaction that is happening with that book. So we list all the objects that are involved. We have the book, we have the table. The table is sitting on the floor, and we always include the earth because the earth is what supplies the gravitational force. Now what we do is we draw a double-sided arrow to show the interactions between each of those objects. So we can see that the table and the book have an interaction because they're in contact with each other, so those would be a contact force. We know that the table is sitting on the floor, so we have another contact force between the floor and the table. And then we know that the earth is supplying the gravitational force on every object that is involved, so we draw a double-sided arrow between the book and the earth, the floor and the earth, and the table and the earth. Then what we do is we draw a dash shape around the book, and we can see that there are only two interactions with the book. We have the table on the book and the earth on the book. So to draw our free body diagram, we draw our horizontal axis, which is always parallel to the surface. So the surface is horizontal in this case. So we draw the x-axis parallel to the surface. That's the first thing we need to do for our free body diagram. And then we draw the vertical axis perpendicular to that. We take our book and we shrink it to a single point so that we draw all forces coming from a single point. The force that the earth supplies is gravity, so I'm going to label that Fg. And I know the normal force is the force that's supplied by the table, so I'm going to label that Fn. So I know I have a normal force and a gravitational force that I'm going to draw on my free body diagram. So the normal force, the table is pushing up on the book, and I know that the gravitational force is pulling down on the book. Now because that book is not accelerating, I know that all forces must be balanced. So I only have two forces, so that means the normal force balances out the force of gravity. And this is how you draw your free body diagram for that situation with the book sitting on the table. All right, so we're going to look at this next situation where we have got a bowling ball that is rolling at a constant speed to the right. So again, we're going to start with our system schema. So for our system schema, we have the ball. We have the lane or the floor that the ball is sliding on, and we also have the earth. In this case, there's no other objects that are involved with the situation. So we're going to draw our double-sided arrows to show the interactions. We can see that the lane and the ball have an interaction. The earth and the ball have an interaction. We also have an interaction between the earth and the lane. And what we're drawing the free body diagram for is the ball. So I'm going to draw my dashed shape around the ball. And I can see that again, I only have two interactions between the two interactions acting on the ball. The normal force by the lane and the gravitational force from the earth. So we draw our horizontal and vertical axis. The horizontal axis is parallel to the surface, which is horizontal. Then we draw our dot to represent the ball. And what we do is we draw our normal force and our gravitational force. So the normal force points up. We label that Fn. And we know that the gravitational force points down. Now, because of Newton's first law tells us that this bowling ball is going to move at a constant speed until acted upon by an outside force. That means all forces are balanced on this ball. So that means that the normal force is going to balance out the gravitational force. Yes, the ball is moving to the right, but we don't care how it got started. We just know that it is moving at a constant speed. So while it's moving at a constant speed, there is no force that is causing it to move. There was a force that caused it to start moving, but at the point that we're looking at, there is no force. So you can check out the video on the mallet ball on Newton's laws, and you can see that a bowling ball rolls at a constant speed through the no touch zone. So here's our drawing free body diagrams for two situations, two very different situations, one moving and one not. Yet both free body diagrams were exactly the same because the motion was the same. Mr. Kavanaugh, the motion wasn't the same. One was moving at a constant speed, one wasn't moving. Yes, but neither of those objects were accelerating. So the acceleration is what matters for the free body diagram. Since there was no acceleration, we know that in both situations the velocity was constant, so the free body diagrams should look very similar, in fact, exactly the same. So this is drawing free body diagrams. I hope you have a great day and an even better
Video helpful? Don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter at Cavi Coaches.